Okay, so here's final review for Unit 0. What I'm hoping you remember from Unit 0 is this. When you look at this type of equation, it's linear. When you look at this type of equation, it's absolute value. When you look at this type of equation, it is exponential. When you see this is a U-shaped graph, it is a quadratic. This is also a quadratic, this is also linear. Those are the function families we were supposed to remember back from Unit 0. We were also supposed to know what that looks like as part of an equation. When I look at something with a square in it, something to the power of 2, that makes a quadratic. This type of equation should make one of these two types of graphs. But if it goes upwards in the positive direction, it means that the value in front is a positive. If it's going downward, like D is, then there should be a negative in front of this somewhere. The only possible answer number 1 has is E. E is the correct answer. Number 2, because of those bars, it's an absolute value function. And I know that the absolute value function is here. Later on, we learned that because there's a -2 inside the absolute value, that we know that the vertex, the bottom of that V, is going to move to the right by 2 spots. It's the opposite of that -2 when it's inside. That was something else that we covered, I think it was in Unit 3. This, because there's no exponent, because we have a -1/3 x, is linear. There's a y and an x, and it's going downward. It has a negative graph, which means it's decreasing. This is the only possible answer that would work. When you have y equals 3, that creates a horizontal line. Another word we used for this was constant. Constant. When you have the variable in the exponent, this creates an exponential graph. The word exponential has the word exponent in it, and it has an x in the exponent. Because this is 1/2, it's getting decreasingly smaller and smaller and smaller. We have a variable to the second power. So anything to the second power is a quadratic, which could be either the D or the E. Because of the negative, it goes downward. It has to be D. Then you had to be able to tell whether something was a function or not a function. If we had a line that the first way to check to see whether something was a function or not a function was using the vertical line test. If a vertical line touches the graph in one spot at a time, then it was a function. Number 7 is a function, 7a I should say. But when we go to part B, if a vertical line goes and touches it in 2 places, it's not a function. It fails the vertical line test. It's not a function. C can be a function, which means every x has its own y, and D is a function. Function, not a function, function, function. Then we have to be able to look at an equation and so here we go. Linear, exponential. And when I look at these with these equations, I start thinking, what kind of graph would this make? This would make a line, and that's increasing. Kind of the opposite of this. It just goes up. So that is a function. When I look at all these, they're all functions except for one. H is not a function. How come? Because this creates a vertical line. All of these, when you have y equals and it's linear, exponential, horizontal line, linear, vertical line, this is the only one that would not pass the vertical line test. The quadratics, the absolute values, those pass the vertical line test when it's y equals. Turning the page. The back side is the part that when I was watching a lot of you do these problems, some of you have some issues with reading the word problems, and there's one like this on the final for sure. 100% guaranteed to have something very similar to number 8. Okay? So, there's a bird's flight. How far is the bird away, and how many seconds? The bird is at the nest, then it starts to fly away. It goes 3 meters away, 3.5 meters away, then it starts coming closer to the nest, and then it starts going out farther, and finally it returns to the nest 8 and some seconds later. What I can imagine when I see a graph like this is how far is the bird away from the nest. The bird's greatest distance from the nest happens at about 7 seconds. 7 seconds. Is that the farthest away it is? True. The bird returns to the nest at about 8.8 seconds. That's true. The bird's greatest distance from the nest happens at time equals 2 seconds. The greatest distance at 2 seconds, is that the farthest the bird is away? No, that's false, because there is a greater distance over here at 7 seconds. The bird was closer to the nest during time is 2.5 seconds. Let me just put a little dot right there, dot, 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 dot. To time is equal to 3 seconds. Then it was at time is equal to 2 seconds. Okay. The bird was closer to the nest during this time than it was at this time. 2.5 seconds to, so let's see. Was the bird closer to the nest? Are these 2 points lower or smaller than this point up here? And I put true. It is. The time between 4 to 6 seconds, the bird was flying closer to the nest. 4 to 6 seconds. The bird was flying closer to the nest. 4 to 6 seconds. What's happening from 4 to 5 to 6? The bird is going farther away. That's why I put false for that. We good with 8? Number 9. This shows the height of a ball and its horizontal distance from the starting point when it was kicked from ground level into the air. So this is your x distance. And then this is how high off the ground it is. So if we were to plot these, what we would end up getting is something similar to this. Kind of an upside down quadratic. A quadratic is facing downward. The height of the ball decreased from a distance of 2.5 to 6.5 feet. Did the distance decrease? Look at these numbers. What's happening to the ball? The ball's getting higher and higher and higher. 52, then 60, then 80, then 84. It's false because it increased, not decreased. The height of the ball was at its greatest when it was approximately 6.5 feet away from the starting point. Let's see. Its x distance is 6.5 feet. Is this height the greatest? True. There's no other point that's bigger than this. 84.5 is the max height. The ball was on the ground exactly 1 time. I put false. It was on the ground at the beginning. It's also on the ground after it went 13 feet away. Think about where it started on the ground, got kicked, and then landed on the ground at the end. It's on the ground at least 2 times in this data. Two more. Ball's on the ground at t equals 0. John kicks the ball into the air, and assume the height of the ball can be modeled as a quadratic function. It reaches a maximum height of 64 feet. 64 feet is right about there. And then lands on the ground 4 seconds after reaching the maximum height. So from this maximum height, it has to be 4 seconds to fall to the ground. I literally take this 4 seconds and go, oh, it's going to go down for 4 seconds, which must mean that it went up for 4 seconds if it's a nice balanced quadratic. As a matter of fact, that's how it works. As long as your starting height and your ending height are the same level. That's how it always works. There's my graph. Last question is number 11. Billy buys light bulbs in packs of 8 for 20 bucks. The shipping cost is $10 regardless of the number of packs bought. Billy has only $120 to spend. So he could buy 5 of those. 5 times 20 is 100. And you'd have to pay $10 in shipping, which is 100 plus 10 is 110. If he gets 6, he would not have enough money to do that. So let's read these things. The domain is, if you forgot what the word domain means, what could you use for x? Your x values, your inputs. That's what domain means. The domain is the set of all integers or real numbers. Integers are the whole numbers without fractions, like 1 and 2 and 3. That's what an integer is. Real numbers, on the other hand, are like negative 1.2. 1.5, 1, 7. The real numbers include all the decimals, positives and negatives. This just includes the whole numbers, positives and negatives. We want all integers because we're getting whole boxes. Greater than or equal to 0 because he can order none if he doesn't want to buy any. And less than or equal to 5. D is the correct answer for that last one.